Okay, this is the next video in our series, and now we're going to look at, make this a short video, we're going to look at reshaping, indexing, and slicing. You can go to the Python file section in our web courses and go ahead and download this particular video, video 07, Reshaping, Indexing, and Slicing. Okay, remember this first line we can omit, but it's just something that gives us the IntelliSense if we're trying to use stuff later on with IntelliSense using the tab button. That enables the tab button. So we'll go ahead and run that. Actually, go ahead and learn how to. We'll restart and clear output. So we're going to restart this notebook. We're going to clear all the output out of it. Okay. So now you see that all the numbers here have gone away. Those are the run numbers in the order that they were running. So go ahead and hit Control Enter. You'll see that we've run that command now. We'll go ahead and import our NumPy libraries. We learned last time that NumPy is the basic math libraries inside Python, and most of them are written in C language and then used in Python, but they're much more efficient when they're written in C. They're compiled to whatever operating system that you're running. Again, Python's an interpreted language, so you don't necessarily need to have compiled stuff. But under the hood, the Python libraries for speed are written in C. And so NumPy, a lot of NumPy stuff is written in a very low language of C to give us speed and efficiency. Anyway, so we've imported NumPy. And last time we learned the range command when we were doing lists, right, in NumPy. So we're going to put in the list method. We're going to create a range of 6. And that gives us our Python list. It goes from 0 to 5 because everything's 0 based, but that's what range does. But that's not NumPy. NumPy has more functionality, and they use the word arrange. So np.arrange 6 gives us the same thing, but now it's in terms of a NumPy array. So it gives us much more functionality, like you can find the min, the max, the mean, those kinds of features that NumPy gives us. So that's why we're going to use np.arrange and not the Python equivalent of range. So now that the equivalent you could have done, there we go, is you could also do numpy.array and then pass it in a list. But you'll see this syntax gets very cumbersome. It's easier just to use the arrange rather than numpy array, create a list. Inside that list I want the range, and then inside the range I want the value 0 to 5. So the shorthand version is to just use the arrange method inside NumPy, and that's what we'll do here. Okay, but just like in Python lists, we can access them by index. Again, 0 based, so 2 is actually 0, 1, 2. So the index of 2 gives us the value of 2. Now this is confusing because that's the index and that's the actual value in the array. But if we went to an index of 1, you see we get 1 there. But that's just because our index happens to be the same value as our arranged. So that's not by coincidence, but it could be confusing because this 2 here is the index. The response is actually the value of the NumPy array 2. Alright, now I think we learned slicing in a couple videos back, but we can also slice within an array, NumPy array. So we're going to remember the syntax is start, end, and then there's the optional step by. So that's your starting value, your ending value, and your step size that you're going to step increments. If this last part is left out, so this :1 is left out, it's going to increment automatically by 1. But if you wanted to go by 2s, you could easily do 2, or any other step size that you wanted to go by. And it's just like in Python, this is this inclusive of the first number, exclusive of the last number. So this is going to go from index 2 to index 4 minus 1, or index 3. So you'll see that gives us 0, 1, 2, and index of 3 does not include the last index of 4. So that's how slicing works. Inclusive of the first number, exclusive of the last number. And then step size was just assumed to be 1. If I did a step size of 2, we should only get the value of 2 because Otherwise, you would step past the bounds of the outside number, and it's exclusive. So there we go. So that's slicing inside a NumPy array. You can also do an assignment. So this array that we have here, we're going to go ahead and assign the value of 100 to this array, and we're going to assign it back into our x. So if we do that, you'll see that it used to be 0, 1, 2, 3, 4, 5. Now we've assigned the value of 100 to this particular slice from elements 2 to 4, not including 4. So that's what's called broadcasting. Now let's look at what we can do when we copy. So let's go ahead and run this code. This is what we did earlier for x. So it goes from 0 to 5. We printed it out. That's what the print method does. Then we're going to create a slice, and that slice is just like we did before. Our slice goes from 2 to 4, and we're going to print out our slice. So you see that we have the two arrays. So this is x, and this is our x slice variable. Okay, let's go ahead and print x. Now we're going to take our x slice, and this is going to be broadcasting again. Remember, we have an assumed start. If it's blank, it's assumed to be 0, and if it's assumed blank on the end, it's supposed to be the full length of it. So whatever the size is plus 1. So that's what this. If you just put a colon, that means everything in that slice. We want to assign the value of 100. So this is our slice variable, and we're going to go ahead and assign it 100. This is our x variable, which has the values of 0 to 5. What's interesting is when we run this, you saw when we printed out x here, it had the 0 through 5 like we expected, but now we print out x and we have 0, 1, 100, 100, 4, 5. Well, we edited slice, but it impacted our variable x. And that's the difference between copying and just being a pointer. So when you do an assignment here, which is what we did, we created a new variable called slice. It's actually a pointer into our variable x. So x has the full 0 to 5. Our slice is a pointer inside of that goes to just the values index of 2 and 3. But they all point to the exact same data. So that's what I mean by pointer. It's pointing into the exact same data for x and x slice. X slice is just a smaller subset of our variable x. So points into our variable x. But we have this other keyword called copy. And what copy does is what's called a deep copy. And we created our new variable x, so we cleaned it up. So I should have printed x. We'll copy this code here. Go ahead and print x. And we'll print x slice. And we'll print x slice after. And we'll print x again. So there's a lot of print methods, so we'll go through this one in depth. Okay, so the first thing here, this output corresponds to this print statement, and that's our variable x, and that should be 0 through 5. Now we've created our slice just like we did before, but we did a dot copy, and so now it's no longer a pointer, but it's its own memory space. So now it no longer x and x slice no longer share the same data; they share a complete copy of the data. And if you modify x slice, so this is our x slice, and then we modified it to values of 100, you'll see that that's this print here. So after we've set all values to 100 inside x slice, you'll see that the two values are 100, but our original x is unaffected. That's because our slice is now a full copy of it and not a pointer into it. So I hope that makes sense. So when you're making slices of your data and you don't want it to impact the original data source, use the keyword .copy at the end of it, and that'll solve your headaches of why is your data acting weird when I do some modification on it. Or in math class when you're trying to do some matrix math and then you want to go back to the original matrix that you had, you don't want it to impact the original one, you're going to do a .copy. So our last video I talked about multi-dimensional arrays. So here we're going to create another matrix, or multi-dimensional array, or matrix. This is a 3 by 3 matrix, and remember it starts with the outside parentheses. That's our full NumPy array, and then inside that we have three 3-element vectors, which correspond to our 3 rows. So that's our first row, that's our second row, and that's our third row. So that's how we create the multi-dimensional array, commas between them. And then if we index it, so the variable x is now our multi-dimensional array. If the first time you index it will give us the entire row. So 1, 2, 3. That's this row here. And then if we do, this is our first row. This is our second, or actually our second index, but it's 0 base, so it's actually our third column. So this first one is row, and this one is column. So let's go ahead and run that. And you see that's value of 3. So we're going to go first row, third column. So that's where we get the value of 3, because it's 0 based. So everything is 0 based, so the rows are 0 based and the columns are 0 based. Now there's shorthand notation. So last video you saw me do this, but you could just do commas inside the parentheses. So this gives you the same thing. I prefer the syntax up here because that's more language agnostic. So this is how you would do it in a C language base or a Java or something along those lines, which are all C based. This is a newer syntax that languages are starting to pick up, but it's not necessarily compatible with all languages. So that's why I prefer this version of it, where you have separate square brackets around things. All right, we can also broadcast, going down this column here, this cell here, you can also broadcast, and remember just colon by itself means everything. So you're saying I want everything in the entire row, and I want the 0 column. So this is going to give you the entire first column, because you're going to say all rows, but only the first column. And that gives it to you 1, 4, 7. If you go here, that's your 1, your 4, and your 7. And you notice that it gives it to you as a NumPy array, so basically a vector. So that's the output. And if you're trying to do math behind it, you may need to do a transpose because of the fact that it's now a 1 by 3 versus a 3 by 1. You can also slice inside, where we had the colon here means everything. Now we're saying I want 0 to 2, inclusive of 0, exclusive of 2. And then I'm going to start at 1, so I'm going to skip 0, and I want to go to, since it's blank, you're going to go all the way to the end. So that's what you're doing here, and you're creating a sub matrix. So 2, 3, 5, 6. If you go up here, it's 2, 3, 5, 6. And how do we get that? Well, we're saying the 0 and 1 row, and I want to start at the first column and go to the end. So first column and second column. And that's how we get this sub matrix. So slices work inside, but this is identical syntax. Oops. Why is that not working? There we go. That didn't work. There we go. What did I do wrong there? That's different. Well, I guess we'll use the comma version of it. There we go. So when you're doing slicing, apparently you can't do the older syntax with the square brackets. But you can also Boolean index values. And this is a little more complex, so if you don't follow along with this portion of it, I don't think anything will impact you for the assignment or anything. But let's go ahead and create 2 arrays. One is going to be our data, which is a random int from 0 to 10, like we learned last video, how to use randint. And it's going to be our shape size of 6 rows by 3 columns. And randint goes from inclusive of the first, not inclusive of the last, so it's exclusive, so it'll go from 0 to 9. So that's why you don't. It's going to create values in the shape of 6 rows by 3 columns. Names is going to be an array of different string names, so Bob, Alice, Charles, that kind of thing. So that's our array, and you'll see its data type is U7, which is strings Unicode. if we go ahead and create, we can say I'm going to look at names. I'm going to go element by element and see if any of them are the word Bob. And you'll see if we go back here, the first one is 0, 1, 2. The third index is, and fifth index is. So you see true, true, and true, and all the rest of them are false. Now going back into our data, if I print out data here, and we comment this out, you can index on a Boolean array. So before we were indexing on slicing, but we can also index on some conditional variable that gives us a Boolean value. And this will be very useful with our data when you want to say, like I have this data and I want to say, instead of the word Bob, you'll say I want to index on all the people that are male, for instance. So this is how you would index into the array data and give back a sub-element list that's just the people that you care about in your sample data set. So that's our full data, and let's comment this out now and look at what this gives us. So now we're going to use this array. Basically, when you do the names double equals Bob's, you get this. So it's going to say, do I want the first column? And you say, does column equal true? And yes, it does. So it's going to give me the first. Here it is. I'm going to print out data. I'm going to print out data here, so we can go back and reference it. So the first row is the name equal Bob. Yes, so I want this entire row. So that should be, this is going to be a new one, so let's do that. Okay. Because I did a randint, it's going to randomly generate new data every time. So that's why the data didn't match up. But now it does. So does true, then I want that entire row. So that's where I get this row from for the first one. Then I get false, false, so I'm ignoring the next two. So this one I ignore, and this one I ignore. Then 0, 2, and 6 is a true statement, so I want that one. Then I'm going to ignore, then I'm going to accept. So I should end with 9, 3, and 1. And so that's how you index using a Boolean array. In fact, if I just put this, what we did here is equivalent of just doing this. We have too many brackets, right? Oops, I didn't do it. Let's put that back. 1 second. There we go. So if you wanted the false, true, 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 false, true, something along those lines, you can do that just as well. So what goes in here is a Python list of Booleans, or an array, and it's going to give you back the indexes of the data that correspond to only the true statements here. So that's how you divide your data. In this case we used the word Bob, but you could easily, if this was like male and this was female, male, female, male, for instance, and you can say I want all the females, you would use you find all the females in the data. What did I do wrong? Oh, I didn't print it out. There we go. So I forgot to print the data out. So where we're saying wherever the names are, or names I should say gender, so wherever gender is equal to female, it's going to print it out. Alright, that's it for this video. Stay tuned for more.